Hi, good morning, everyone. Thanks for taking the time to join us this morning. My name is Mike Torito, and I am the technical consultant for the Siemens RTLS system. I also represent the IID, Industrial Identification Portfolio for Siemens. So that is RFID, optical identification, and real-time locating. Today, what we're going to be discussing is RFID and RTLS and how Chasm's cloud-based Locera application can give you and your customers a lot more fidelity and accuracy and logic in the data that could be generated from an RFID or RTLS system. So the first question that's probably going to come to most people's mind is, what is RFID and how is it different from RTLS? Well, RTLS, as the name suggests, real-time locating system. This allows us to be able to track assets in real time on a dashboard anywhere in your facility. With Locera's help, you can take that and take it down to the mobile devices. And what this does is allows us to place a transponder on any asset. That transponder is going to send out a blink, and that infrastructure basically picks it up, sends it to the gateways, and the gateway sends it to a locating manager where we process and basically geo-position that individual tags X, Y, and Z in the environment. Locera is going to take that information and then make it more useful and then pass it to the customer's MES. So RTLS is placing a physical transponder, a battery-powered transponder on an asset, and it providing us a blink, if you will, with its general location. RFID, on the other hand, is only going to give us information when an RFID tag passes a certain reader. These readers are much like the easy tag system that you use in the major metropolitan cities, where you pass underneath a toll bridge and a reader automatically scans that tag. There's also, just regular low frequency RFID, like you see at the grocery store or your department stores. Whenever you walk through the scanners, the buzzer goes off if you've got an electronic device. Also, badge in, badge out of personnel. When that person uses their key card on that badge and you hear the click, that's RFID. So RFID is only going to give you data when that tag physically is in the presence of that reader. So it is a great application to use RFID as portals over entry and exit doors of a warehouse if you just need to know if an asset has entered or left a warehouse. If you need to know exactly where that asset is, that's when we position to a real-time locating system. So when we talk about RTLS, we've got a couple different types of transponders. The first is the 4030T. It's battery powered and has a lifetime of anywhere from 12 to 24 months based on its use. On the far right is the 4083T. This is an e-paper tag which allows us to change the screen based on geographic location. So we can change it to say, in progress, stationary, workstation 12, and also put barcodes, QR codes, scannable data on there as well. And it also can be updated in real time. Middle transponders are CAN bus tags. So this is for buses, forklifts. Anything that has CAN bus functionality, we can pull that data and report it to the system as well. Again, the infrastructure, transponders send out a blink. Blink is captured by the gateways. The gateways send it to the locating manager. The locating manager is the base software that comes with the Siemens provided system. So you see this image on the right. It's really just bubbles that are bouncing around a facility. For some customers, that's enough, but a lot of customers need a whole lot more, and then that's when we'll transition to Locera in the next few minutes. Now is a video, our E3. You'll see is that it said it was in progress, and as it gets put into, we're going to now it says it's in storage. Again, QR codes, barcodes, any type of information you want displayed on that particular screen, we can have it displayed. So real quickly, when we talk about RTLS, we want you to know that you can get accuracies all the way down to 12 inches, but we can also give you accuracies up to 50, 100 feet. It's scalable, so all of our devices come with ultra-wideband and 2.4 technologies built into them. So it's not a matter of this. One thing that separates us from the competition is if you want outdoor use or indoor use, you have to buy a different device for each, whereas us, it's flexible, it's modular. Every device comes with both technologies as well as multiple locating technologies and methodologies as well. So for instance, if we want to triangulate position inside of a warehouse, we need 4 devices. But if we just want to know, like the image we're showing here, if we want to know if something's in this top room, we would put 4 devices in that room. But if we just want to know if something's in that room and we don't need to know exactly where it's at, we can do that with just 1 device, and that's called presence mode. So there's a lot of different ways we can make our technology, we can manipulate our technology to make it display exactly what we want to see. I'm going to speak real quick. This image is quite large and it's going to tie up all my bandwidth, but this is a typical facility of the future, of now. I want you to see that all of these pieces and parts are going to be moving in here. We have shipping and receiving, we have inventory, forklifts, we have trucks, we have people that's managing all of this equipment. We have cranes with a transponder on all these moving parts. So you put a transponder on all these moving parts. Now we have X, Y, and Z position of all of those assets. We also have timestamps of all of those assets. So we know the second a material arrived, we know how long it's been sitting in storage, we know how long it's gone through the process, how long each machine has interacted with that, which forklift picked it up and moved it, where it's been put in inventory, and what time it leaves your facility. All of this is based just on the X, Y, and Z data that our system generates. Now, that data is great, but what I like to tell people is if you're using RTLS and RFID just for locating, you're missing out on a huge possibility of what is available. Location data is important, but what you're going to see when we transition to Locera is what they're going to do with all of that data. We can talk about use cases. Say, for instance, one of your machines goes down or goes out of calibration, then you would be able to know every asset that was affected by that miscalculation. So instead of having to recall, 100,000 products, you may only have to recall 2. You'll be able to see heat maps of where your assets are moving. You'll know dwell times of how long an asset has been in a position. Location, Locera is going to show you sequencing that they use. Collision avoidance methods. One thing we always see too is when I play this video again, we see that there's a crane that moves. Well, anytime a forklift or a person goes underneath that crane, you could technically disable that crane to where it does not move, and that just prevents any further safety hazards or safety issues. One important key concept to remember, talk about use cases. One of the best use cases that separates our technology from everyone else's is the ability for us to locate in difficult locations. We've integrated with Atlas Copco and Apex inside of their smart tool, and we're able to change the torque settings of that tool in real time as that employee moves to different stations around that vehicle. So this is implemented in two of the automotive manufacturing centers right now, controlling their process. So we talk about 12-inch accuracy. Just think if you broke this vehicle down into 12 different stations or 12 different geofences, you could theoretically change the torque settings on 12 different tools, 12 different bolts, all within the same vehicle. And last point I want to keep in mind is what separates us from everyone else is that, we can locate in difficult places. We always talk about line of sight, but we locate underneath car bodies, inside of car bodies, down to an accuracy of 12 inches. And keep in mind that this vehicle is moving along the assembly line the entire time an operator is underneath it, manipulating the equipment. Last thing is worker safety. It's very important. Transponders can be placed on employees that are working in hazardous areas, confined spaces, any difficult locations, or even if you just want to deal with contact tracing for COVID or, the next round of COVID or cold and flu season, et cetera. So, if OSHA or if unions allow you to put transponders on people, it gives you the extra ability to be able to assist them in hazardous environments. With that said, I want to hand it over to Chasm, and And yeah, Sean, if you want to go ahead and take over from here.
Okay, great. Thank you, Mike. I appreciate it. And I want to say thank you to everyone for joining us today to learn more about Locera, our easy-to-use location intelligence platform by Chasm. My name is Sean Sandoval, and I am the president here at Chasm. And we are located in the tech hub of the world here in Seattle, Washington. And we are a software-focused company that delivers value to our customers in three primary areas. We develop software products and tools, first and foremost. Secondly, we sell products via our digital platforms business, and Amazon Web Services and Siemens Industry are two examples of the primary platforms that we focus on. And third, we have a consulting arm of the business that helps clients assess, take inventory, and really build technology plans for implementing manufacturing execution systems. Now, before we move on to the Locera section of this presentation, I would like to level set around a few operational challenges that location data could potentially solve. You know, ask yourself this question: what do you waste the most time searching for in your facilities? Well, on this end, we're constantly being customer-centric and trying to solve problems at Chasm. And, you know, the low-hanging fruit that we came up with was misplaced items. You know, having an impact on losing time just searching for proper materials, tools, and equipment when they're needed. Also, the inefficient material movement. And so that has an impact on production scheduling and time to completion. Inaccurate business systems is another challenge that we've come across. And so being aware of production line availability, material consumption, and scheduling as well. And, you know, the other major challenge we see is work in progress awareness. You know, there's oftentimes a reliance on humans to update the progress of a particular production work order, material usages, or just the stages of production. So manufacturing is often highly automated, but businesses' location awareness is often dim at best. It may be the last undiscovered frontier for massive efficiency gains for organizations. And so current methods of logging location information typically fall into one of the following levels of location automation. And so I want to emphasize location for this particular slide. So we group it into three categories: manual processes of acquiring location data, semi-automated, and automated. Companies with manual processes track location via paper-based logs. An example of this would be, say, an operator writing down a pallet ID number into a logbook with a time date stamp of when it was used or moved. You know, tracking of this event is not always real time and can have an impact on business operations from a scheduling perspective. Semi-automated approaches improve and start digitizing location information via data entry or some type of scanning mechanism to store the information into a system. And finally, automated systems have some level of device infrastructure. You know, we just listened to Mike's presentation there on the types of infrastructure or devices that are available from Siemens. And these enable automated location position, identification, and data storage without human intervention. And this information is fully organized and available for consumption to the right people and systems in real time. And so Locera really enables users to rapidly move from manual-based location tracking to fully automated location intelligence. And here at Chasm, we say it's all about location, location, location. Locera provides actionable location data to improve really how you operate. We can view the location of anything you can attach a transponder to in real time and from anywhere. We can view identification information as well of anything you can attach an RFID tag to at point in time information from anywhere. And we have made historical records of location data readily available as well for the purposes of reporting. And understanding that users of Locera are not always glued to their computers, notifications were a major priority when we built the software, so that the notifications are provided as a standard option and can be configured with any number of rules that can be triggered. So once again, it's about having awareness of critical assets or the things that you are trying to track when you need to know. I would also like to emphasize that Locera was built as an API from the ground up, so it could act as a data hub for valuable location data. Locera essentially successfully democratizes this information and creates an incredible opportunity for businesses to know where anything is from anywhere. Our focus was to make automating location data simple and accessible. A request that came in from one of our automotive supplier customers, and a key highlight of asset tracking is our ability to monitor asset usage, repairs, and the costs associated with those repairs, and then report on this information natively or share it with an existing maintenance system via that API or webhooks technology. You can assign any level of rules inside of Locera. For example, you can assign an asset to an area, so it will remain in that area, or you can designate an area as off limits to a particular asset type. And when a predefined event is triggered, notifications can be sent. Sequencing is also a major feature within the software, of which we'll walk you through here shortly in a demo. And this gives us the ability to track assets through a predefined order with a predefined time to maximize the flow of assets to be more efficient. And all of our customers, to all of our customers, historical records are always important. So within Locera, we provide an easy-to-use reporting tool to support any number of data acquisition and reporting styles. So we have export tools that support a number of different formats, including Excel, CSV, PDF, etc. And from an integration standpoint, it's important to know that location data, when I made the comment earlier about a massive opportunity, there's existing systems, which we call systems of record, typically are like business systems like JD Edwards, Oracle, SAP. A lot of these systems need some level of location intelligence, or you could create a major optimization opportunity there. We have a powerful API and also now support webhook technologies that support a lot of the modern IT integrations. So the availability of that can, be that data hub and move the information in a very easy, usable web format. And now I would like to share a bit about how we do it with Locera. Our technology choices for Locera were made to simplify not only our feature set, but the IT infrastructure and the management of the software. Our API and webhooks allow for modern connectivity to other systems. Our role-based access control provides our customers with multiple levels of application access. And right now we support barcode and QR code scanning with your cell phone. So this enables our customers the ability to get started today if they would like. And you will get the chance to see our virtual boundaries here in a moment, but please note, this is a major component of our software that drives much of the location intelligence. And finally, we harness the power of the cloud, which enables elastic compute power. So there is no guessing. Our customers do not have to guess about IT infrastructure, and it's always available when it's needed. It also allows for our software to be globally available, and the software updates are readily available. So essentially our goal is to reduce the technical debt that companies typically take on when implementing these types of systems. Okay, so a little bit, I want to show you a graphic of how it works and the pieces and parts that actually, are built for the actual fully automated system. So, at the lowest level of the things you would like to track, you're going to use transponder or a combination of transponders and or RFID tags, and attach those to the things you would like to track. Those items are going to be consumed their location through a gateway or a reader. Gateways are for RTLS transponders and readers are for RFID tags. Those devices then send it to a central computer that we refer to as the Locera Edge. And this creates a secure connection through a device to the cloud. And that is where you would access the Locera application. So this is a visual representation of what could be expected in a fully automated location tracking system. And so this is the part where I will hand it over to Calvin, who is the architect of Locera, and he's going to walk through a demo of our software. And thank you for your time. And Calvin, I will hand it over to you.
Is it showing? Okay. Cool. Thanks, everyone. My name is Calvin. I am the lead software architect of Locera here at Chasm, and I'm just going to kind of give you a brief breakdown of what the software looks like in a live system. Here we're actually showing one of our large-scale test facilities at one of our partners over in South Carolina. So with the power of the cloud, I'm sitting in Boise, Idaho right now, and I am able to see what's happening over in South Carolina, which I think is pretty nice. One thing you'll notice is I'm logged in with a pretty high-level user, so I have access to everything. One thing that we do have is role-based access control. So different users will have different levels of access and different levels of what they can see and control. So for an example, a base user basically only has the dashboard for RTLS. So they can't hit any configurations. They can't touch any of the data that you don't want them to. So as you can see right on the map, we have a couple tags kind of moving around this morning. We don't ever really know what's happening over in South Carolina, so it's nice that some of them are moving for this webinar. But other things to kind of notice here on the dashboard is we've got our list of transponders. We only have 10, but if you were to have hundreds or even thousands of them, we do have quick filtering, so you can find the tags you're looking for easily, even if you do have a large amount of them. And then we do have some just other basic information on what is happening with each one of these transponders at any given time. This transponder that I selected, side panels, it just gives you a quick breakdown of what type of transponder we have assigned it as and what group this transponder we've assigned it to. And these are 100% customizable by the customer. So if you have a specific type you'd like to use, no problem. You can put that in and assign your transponders to that type. And then we also have a quick area history of where this transponder has been or is currently at any given time. And then the final thing to kind of highlight on the dashboard is we have a quick little alert box to show, hey, we've got two transponders that we've designated with special rules to say when they are sitting in a specific area for too long, we need to be notified about that. So right now, side panels AAB and Cart1 are both in alert, and you also see that we have a little bell icon up here to have those. On top of that, emails have been sent out for both of those transponders to the designated user saying hey, these transponders are an alert, maybe you should go take a look at them. The next thing I'm gonna just kind of jump to is the configuration of the transponders themselves. So when you first load up Locera, after you've connected to your RTLS system, you will see every transponder that's registered inside of the RTLS location manager, but none of this extra data. So there's no hand inputting of data. It is all here immediately for you to work with. And then you can begin customizing this data and working with it as you would like to utilize it. So we've just added a couple simple fields, like what you would like to see it named as, because node key 51133 is a little hard to say in conversation. But then we have groups, types, and then just some other little things to make it look nice on the map. On the right-hand side, we have location customizations. And what these are is where you can assign certain alerts to this transponder. So if this transponder hangs out in an area 1 for more than 4 minutes, that's when that alert gets triggered. Just another kind of quick thing to show is to show how customizable everything is. Here's my list of groups and types that I've configured and the customer has configured for this system. And like I said, if we want more, click a couple buttons, hit save, and you have everything you'd ever need to customize it to your heart's content. The next major piece is our geofence configurations. So geofences drive a lot of the logic that exists inside of Locera. So from here, I can come in and start creating geofences manually, or if I want to, I can simply, so I'm just going to give this a quick name, save it, and now it's part of the system. Now I can manually come in and start adjusting the X and the Y positions of each corner of this to get a much more pinpointed accuracy. And I'll talk a little bit more about some other stuff we're working on to make this even better near the end of it. The next major part of Locera is the rules creation and the rules engine itself. And the rules engine is what allows you to create the alerts to make you notified of things that are happening in the facility. So we have a couple different types of alerts. We have a default alert, which has some pretty basic rule sets. And these are basically going to be used for if a specific type of transponder enters an area or a specific type of transponder leaves an area that you want to be notified by that. But then we also have the ability for proximity rules. And these gives you a little bit more customizable options of, hey, if 2 transponders get too close to each other, or a transponder spends too much time next to another transponder, or in a specific area, we need to be alerted about this. This originally came from when COVID-19 hit. We wanted a way to do contact tracing, but we started to think that there was a much more broad appeal to this type of technology and what we could do with it. The next piece that I'm going to take a quick run through is what we call sequencing. And sequencing itself is the idea of setting up a specific sequence that a type of tag needs to go through. So in this example, we have this type of tag, CR alpha group, needs to go to these specific geofences and spend a specific amount of time in them. And from there, we can come back and report against those and say, when it ran through this one, it went to step 1, which was good, but then it went to a step that it wasn't supposed to. So now we have a record to say these tags did not follow the way that they needed to. And then here is an example of it following the sequence as intended. The next thing we kind of have that's available, and this is good for sending out to other systems or if you want to look back on your data, is the reporting functionality of Locera. This is a really simple report that shows the history of every transponder and every area or geofence that it has entered and left in any given amount of time. And from there, you can easily export it to any system that's available up here. And all of this data, of course, is available via the API so that it can be imported into any other system of record you'd like to use. We also have the ability to look up the history of an individual transponder and where it has been in the facility. So I'm hopefully going to click one that has some, and yep. So you can see that between the past few days, side panel CCCD has kind of stayed in this little area by itself. Another option we have along with that is the ability to take that data and just place it with a heat map. So you can see how much it has been hanging out in those positions. And of course, we can stack as much as we want on top of each other to see where high areas of traffic have been. That gets us to the end of RTLS and what its kind of functionality is. The next piece is, of course, our integration with RFID and what it is possible. And RFID inside of Locera means both RFID, but we also include barcode scanning kind of in the same vein, because a lot of the technology that we use in the back end kind of follows the same process. So just for fun, last night when we were out at dinner, I scanned a QR code and registered it inside of Locera. And you can see that I said, oh, I was in Arizona. I wasn't in Arizona, but that's where I assigned it as. And this is the time that I read it into the system. So just kind of a quick history of what's happening on the RFID, and then just some basic metrics of what's happening. The next piece we have to this is going to be very, very similar to what you just saw, but it gives you a much easier way to filter that data out to say from when to when, and just a little bit more of a filter of what type of locations you can find where tags have been and what they're doing. And then of course we've got the configuration of readers. So we have our RFID readers and our barcode readers, which are basically cell phones. So one thing I really like to point out with this is just how easy this is to configure a new reader into your system. So I'm just going to select this existing one. But when we register a new reader in the system, all you need is the OPC UA address of the reader itself. And every 30 minutes, the Locera Edge connector calls up to the cloud and says, hey, do you have any new readers for me? If it does, it brings down that information. And then it scans looking for that address. And once it's found that address, that reader is now available inside of Locera, and it will become a read point for you to see. Barcode readers quite aren't as nice as that for auto configuration, but it allows you to just create a new barcode and say where you'd like it to be registered inside your facility. And that is where it's going to assume you are when you scan from that barcode. And then just some other little basic configuration is if you want to add some more information to individual RFID tags that you've read, and then here's how you can register your locations and your actions themselves. Final thing that's kind of, we threw into Locera, one of our automotive customers kind of requested this because they want to track tools throughout the facility. And they said, hey, is there a way that we can track both the tool, but some of the records that go along with the tool? So we created a service record management system to say, this is a type of RFID tag. Here's its real name that they used inside of the facility, say it's PB101. And then we can add individual records to it to say it cost X amount of dollars on this date. And then we can start running reports against that data to say total cost of ownership, or are we spending too much repairing this thing that we don't need? The final option I'm not going to pull up because it will mess with our cameras, but this option on the bottom here, scan, when you log in with a barcode user, a barcode scanning user, this will be your option that you have. You can click this button, it'll load up your camera, and it'll start looking for barcodes and QR codes to register into the system. One thing I'd like to do is just show a quick video of sequencing, because a video of it is a little bit better than me trying to explain it. So I'm going to pass it back to Sean and the slide deck with the video in it.
Okay, so thanks, Calvin. So what you're looking at here, and the reason why this is recorded is we had somebody moving a tag around at the test facility so that we could actually capture this, but it's a little difficult to do it on demand. So because we captured this, wanted to show this is a sequence, and we picked something really simple like an operator route or a guard route. So what you're looking at here is a guard doing door checks, at a facility. So door 1, they should go first and foremost, and that door is in area 1, as you can see here on that first line of a sequence. Okay, and the order should be priority number 1. Okay, and then they go to door 2, which the order of the sequence should be 2, and then the order number 3 is door 3. So they need to go to door 1, door 2, and door 3. So as that sequence starts, you can see we deselected all these tags. We selected the guard to watch this route. So as they move to door 1, you'll see, or they were at door 1, and now door 2 showed up here, shows they're moving through areas 1, 2, 3, and you should see door 2 pop in here in just a moment, or door 3, there it is. And then if we go back to the sequences and we check the route, and drill down on this, we can see the steps were conducted in the proper order and so on. Now let's take a look at what happens if the sequence goes out of order. So now they're going to, the guard is traveling to door 3. And from there, they are going to travel to door 2. And then finally return on the route. We go back to the sequences, and you can see here on this sequence, it was completed, but it was out of order when we drill down here. So sequence out of order, sequence out of order. So this example is showing these stages or sequences. However, this can be applied to any number of processes that have stages that you would like to track from a WIP standpoint. And then I'll pass back over to Calvin. He's got a quick final comments on upcoming roadmap components, and then we will close this out and hand it back over to you, Katie, for any questions that may be out there.
Cool. Thanks again, Sean. One thing we really see here at Chasm as a big value add is the ability to integrate augmented reality and to be able to use augmented reality in a real way to find your transponders or your items inside of a facility. A big problem that we're kind of running into is people have very large facilities, and a 2D map just doesn't give you as good of a location. It doesn't represent it as much as you could. So we can then take that, but we can take that data and put it into a 3D space and be able to find things very accurately. The next thing we can do inside of an augmented space that's a little more difficult to do in a 2D space is hyper accurate geofences. So we could take an augmented space and individually place the markers to create the geofence in that augmented reality space. So you can get down to a super accurate, if you wanted a geofence to be a table, we could accurately look at that table, place the geofences, and now you've placed it in that area. Version 1, we're guessing, is going to come out in the next few months, because we're going through final testing with that. Version 2 is going to start integrating AR glasses themselves instead of just your cell phone. So you could use something like a Microsoft HoloLens to just look and do these actions instead of having to use a cell phone. We'd also like to integrate further barcode scanning along with the AR glasses so that you could look at a barcode or a QR code to register it into the system or scan it into the system. And then something else that's a little bit further down the road in the AR world is the ability to create irregular shaped geofences. So right now, we only fully support 4-cornered geofences, but we could start supporting L-shaped geofences or W-shaped geofences, however you'd like to follow that geofence. We could follow a conveyor down a path completely if we really want to. But so we're working on that as well. And then kind of something that's going to go along with the augmented reality, because it becomes a mobile app, is the ability for push notifications for notifications when something isn't right. And with that, I'm going to pass it back to Katie for any questions.
Awesome. Thanks, guys. Like Calvin said, we're going to open it up for a few questions. So please be sure to send those in if you haven't had a chance yet. I'm going to start with the earlier questions that came in about RTLS and RFID itself, and then move to the Locera questions. So these first few are going to be for you, Mike. Let's start with this individual wants to know, what are the dimensions of an RTLS transponder?
Yeah, so some of the smallest transponder that we have right now is roughly about 3 inches in length and about 1/2 inch wide and 1/2 inch tall. So basically the size of your thumb. The ePaper 3 transponder is about 3 inches wide, about 2 inches tall, and slightly less thick than a cell phone. So like an iPhone 11 or 12, it's about the same width as an iPhone 11 or 12.
Awesome.
And then and then the CAN bus, the one we were showing, is probably about 6 inches long and about 2 inches wide, but that's made to be mounted inside of vehicles and such. We do have other devices in the roadmap to be released later this year, where those widths and heights are being compressed down a little bit, as well as offering rechargeable options for some of the transponders instead of battery powered.
I would also like to note for our audience, if we get to your question and you would like further explanation, just send in another one and we can circle back to it. Another question for Mike. In what format or protocol is the location data provided to other systems? Right,
so using the RTLS locating manager, it's basically just TCP/IP, as well as database access. That's realistically where we end. But with Chasm, it's APIs, it's webhooks, it's multiple other avenues.
This individual would like to know, what is the use range and is it PLD rated?
I'm not familiar with PLD. So someone could, text that in or shoot me an email. I can look into that. The range of the devices, depending on the location method that we're using, these devices have an antenna that is omnidirectional, so it sees 360 degrees. If we're looking for maximum range on these is going to be about a 300-foot radius. Minimum range is 15 feet. So if you want an accuracy of 12 inches, the devices are going to be probably 20 feet apart from each other. But if you need an accuracy of 10 feet, they're more or less going to be 100 to 150 feet apart.
Another question surrounding use range and location. What is the average square foot coverage per 4 antenna set?
Yeah, that's a good question that we come across, and it doesn't exactly work like that. It's difficult to say 100,000 square feet equals this total number of devices. But whoever wrote that question, I can answer it very specifically if you give me an idea. We've got some general cheat sheets that say you in this square footage use this amount of devices, but the tricky part here is it depends on what level of accuracy you need, because accuracy is based on the density of devices, and we offer every accuracy range from 12 inches to 10 feet to anything in between. So I could say, I know for a 300,000 square foot facility, if you want 10 foot of accuracy, I think it's 12 devices, something like that. But if you want 12-inch accuracy, you're talking probably a couple hundred devices. So it really all depends on what level of accuracy you need. But if you want to get with me separately, I can tell you, give you a better idea of coverage. Again, 300 to 12. It really depends on accuracy.
And then a follow-up from the same person who asked that question: what's the frequency of broadcast?
Perfect. Yeah, great question. So we use two different locating methodologies, or we can use two different locating technologies, and those technologies or methodologies allow us to use either ultra wideband, where we're operating in, I think it's like 4.3 gigahertz, as well as 6.5. So we're operating in the ultra wideband space. We also have another technology we call two-way ranging, which is more of a phase technology, and that operates solely on the 2.4 network. That's what allows us to work indoors and outdoors. And like we alluded to earlier, both of those technologies and both of those methodologies are in every single device that we sell. So you are basically protected regardless of future-proofing your devices, to where if you want to change your locating method a year from now or your accuracy a year from now, it's completely up to you.
Circling back to another transponder question, what's the battery life for an RTLS transponder?
Right, the battery life of the transponder that's the size of your thumb, I think we were talking earlier, it is 12 to 24 months depending on use. Each of the transponders has pressure sensors, temperature sensors, and an accelerometer, and we can wirelessly change the blink cycle. So for instance, if that transponder is blinking once a second, the transponder that's the size of your thumb is going to last a year. But if we tell it only to blink once a minute, you can do the math that it'll last, 2 years, something like that. So that transponder that's the size of your thumb lasts, it's a replaceable battery, but the e-paper device, the battery life on that is about 6 months runtime, but it is rechargeable. So you just put it back in the docking station and it recharges. Again, we do have newer models of all of these transponders coming out and later this year, and the expectation is 2 to 5 years on battery life there.
All right, at this point, I would like to move to some Locera specific questions. So Sean and Calvin, these are going to be for you guys. First, let's start off with, how much does Locera cost?
Great question. We have put a QR code on the slide that should be showing to everybody, but you can simply go to locera.io/pricing, and we have public pricing there, just so that you can get an idea of what the costs is. It is subscription based because we're leveraging, infrastructure as a service. And so all the information should be there. If there's any additional questions, you can just shoot us a quick email and we can talk through it if you have a particularly unique situation.
All right, next question. How long do you store the data?
That's another good question. So the data, we have a 30-day retention policy, but depending on an organization's retention policy, we do have options to store that data on a longer term basis. We would just need to understand what the retention policy requirements are from the customer, and have that discussion, because we do have some customers that require 3 years and up to 7 years of data retention for all data. So it just kind of depends. However, right now we do offer 30-day worth of retention.
And then this seems to be the last question that we have right now. So if anybody has any more questions that they would like to get to, please be sure to send those in the next minute or two. But for now, what is the best way to access the location data?
For us, the best way to access it is the API or to configure webhooks. Everything inside of Locera is API accessible. And that is the idea behind that, is to make that data available to other systems. We want Locera to be kind of the data hub for other systems to use and make more sense of the data, because Locera is never going to be a system of record, but we can definitely provide value to external systems of record.
Another question that just came in for Mike about RTLS and RFID. When would you use RTLS over RFID?
Great question. Almost every facility we go into, there is a use for each technology. So every facility we walk into has both RTLS and RFID. And you've seen Locera has the capabilities to integrate those two pieces of data together. RTLS, we're using active transponders. So there's a battery associated with them, and the tags are slightly more expensive than your standard RFID tag. So typically we say you would put RTLS on large containers that are carrying lots of small pieces, high dollar assets, or assets that you absolutely need to know the real-time location of at all times. RFID would be good for if you're making widgets and you're placing 100 widgets in a container, and then the container gets put into an inventory, into a warehouse. You could use RFID on the widgets, RTLS on the one container, and you would be able to track that container and all of those associated pieces throughout your entire facility. Another use case with RFID might be for when you just want to know if a particular asset has passed a certain point. For instance, if there's a one-way road that goes into a room and you see an RFID sensor has tripped, you can automatically write the logic that assumes that this asset is now in this room. And then when it triggers again, you know that that asset has left that room. So again, RFID is only going to tell you when that asset passed that reader. That's all you're going to know is reader 123 rang true with tag whatever at 750. So again, check in, check out, verification, et cetera, et cetera. But there's always a place for both technologies. If you want to follow up with me separately afterwards, we can kind of walk through that. But yeah, every case is unique. There's always a play for both technologies simultaneously.
We have another question for Sean and Calvin. Can the software and data hosting be deployed on premises?
So there's two answers to that. So from an RFID standpoint, the answer is yes. From an RTLS standpoint, the answer is no. RTLS and real-time just location awareness in general is quite complex. And so we need the compute resources in the cloud and the infrastructure to support what is actually happening with the quote unquote, the intelligence piece of the software. And so it's a no on premises for RTLS, but it's a yes for RFID only. But if they start off with RFID and they want to, include RTLS, then obviously that would have to be a cloud deployment.
All right, that seems to be the end of our questions. If you have any last minute ones, feel free to send them in now or reach out to any of the speakers. You have Uli's information on the screen here, and any of the KAASM guys can contact you via email if you have any follow-up questions. Same with Mike. Thank you to all of our speakers, Mike, Sean, Calvin. Your education and insights were very valuable today. And to our guests, we thank you for your questions and your participation. We hope you enjoyed the presentation and demo today. At this point, I would like to conclude the webinar.